Okay, this is lesson 11, and we're on to the new part of the chapter, 1.3, and we're going to look at scatter plots and linear trends. So in the previous section, you have seen that it is often useful to draw a graph to help you analyze and understand data. A scatter plot is a particular type of graph used to discover what relationship, if any, exists between two variables. So what we're going to be looking for is we're going to take two things and we're going to see if there is some kind of correlation, meaning um, does height of a person correlate with shoe size, right? So that's kind of an example. So points that represent the data are drawn on a coordinate plane. That just means a graph. So you can just write in graph. Then the graph is examined to see if a trend or correlation exists. And you can examine if the points all seem to cluster around a straight line or if they are widely spread out all over the graph. So if the closer they are to the line, like if it looks like the points are really clustered close together, then you have a strong correlation. There seems to be a real relationship between the two things that you're comparing. If they're spread out, what that suggests there isn't really a correlation. It's weak. Okay. So if there appears to be a correlation between the points, you can draw a line of best fit. So you try and draw a graph line through the points that matches their trend or their direction. This is a line that shows the general trend in the data, and it does not pass through all of the data points, but instead is drawn so that approximately the same number of points appear above and below it. Okay, so the same number of points appear above and below. Now, it doesn't have to be dead on perfect, but do your best. If the points cluster close to the line of best fit, there's a strong correlation. If they are spread further out, there is a weak correlation. And if you're wondering what the word correlation means, it is the degree of relatedness between variables. Okay. So using a line of best fit, you can find the following information about the relationship between the variables. You can look at the shape. It's either going to be linear or nonlinear. So does your correlation make a line or does it curve? Strength, weak or strong. So that will be dependent on how closely the points are clustered to the line. The direction. So positive will always trend up and negative will always trend down. And then there are things called outliers. So if you went around and sampled the entire school, took their height and their shoe size, there is going to be the odd person that is not going to fit the trend. And those are what we call outliers. So you might have a short person with really huge feet, right? Or vice versa. You might have somebody tall with really small feet. And they're going to stand out on the graph because you'll see them. Their point will be way off the line. Okay? Those are called outliers. So example one. For each of the scatter plots below, describe the relation. So we're going to determine, is it linear or nonlinear? And then if it's linear, is it direct? Meaning, does it start at 0 and 0, or is it partial? What is the direction of the correlation? So that is either positive or negative. And then what is the strength? Strong, moderate, or weak? And are there any outliers? Okay, so let's flip it over and take a look at the four graphs here. So here's a bunch of data points. Okay, and you can kind of see the trend. Um, Here's B, bunch of data points. You can kind of see the trend line. Here are your outliers. You can circle them. Here's C. The points are kind of all over the place. Is there really a correlation here, or is there nothing related between y and x? D, it looks like there's a correlation, but it doesn't look linear. Okay, so we'll go to the next page here. And it says for A, and I'll just read it out while keeping the graph on the screen here to explain it. The data points seem to form a straight line. So the graph shows a direct linear relation. So if we were to draw a line through here, line of best fit, I would say it's something like that, right? So you got a direct linear, starts at 0 and 0. It's positive because it moves up left to right. And the points are quite close together. So we would say this is a strong correlation. So whatever they're comparing seems to follow a particular pattern. And there are no outliers. I don't see any random points scattered anywhere. Okay, B. The data points seem to form a straight line, but it does not pass through the origin. So the graph has partial linear relation. And that's because if we did a line of best fit, I would say it's right about there, maybe. Like that. Okay. And yeah, it's partial. It doesn't start at 0 and 0. It starts way up here. It also has a negative slope, not positive. The points are more spread out than the one above. So we would say this correlation is kind of moderate or medium. Okay. And then there appear to be outliers. The point at approximately 1.2 and 1, this guy over here, and the one up here at 4 and 5. Yeah, those are what we call outliers. Okay, C. There appears to be no relationship between the variables. The data points are all very spread out, and no trend is apparent in the data. So you don't even try and draw a line. There's nothing there. These two variables have nothing in common. There's no trend. They're not even related. D, the data points seem to be a nonlinear relation, and it actually looks quite exponential to me. There is a positive correlation because it starts in the left and rises to the right. The points are quite close together, so we would say this is a strong correlation, and I don't see any outliers. And that is the end of Lesson 11, Part 1.